Hi GOR, this is Unit 3, Lesson 2, and today we're going to talk about congruent triangles, which is really the whole rest of this unit is on congruent triangles. So congruent triangles are triangles with the same shape and the same size. I could literally cut them out and put one on top of each other and they exactly match. This means all their corresponding parts, which may be their corresponding sides, and their corresponding angles have to be congruent to each other. So let's look at a congruency statement. So when triangles are congruent, we can write a congruency statement. So I can see that on the left I have triangle ABC, and on the right I have triangle FED. Now I'm saying that triangle ABC is congruent to DEF. Can you see how A is the first letter? Angle A is congruent to angle D. And look how I have them marked right here. They each have one little curved arc mark there. And then B is the second letter and E is the second letter. B has two little arc marks and so does E. Those are congruent to each other. And C is the third letter and F is the third letter. C has three little arc marks and so does F. So the order of the letters tells us which angles are congruent to which angles and also which sides are congruent to which sides. See how AB has one little dash through it? So does DE. And look, AB is the first and second letter and DE is the first and second letter. So the order of those letters is important. And BC is congruent to, see how it has two little dash marks? BC is congruent to EF, and the last one, DF, has three, is congruent to AC. Okay, so to be congruent means that all three corresponding angles are congruent to each other and all three corresponding sides are congruent. The order of the letters tells us what is corresponding. Sort of what is matching up to each other. Now, what is Cpctc? We're going to touch upon that in about 2 days, but Cpctc stands for corresponding parts, and we can use this abbreviation in our proofs, on tests, on the regions. Corresponding parts of congruent triangles are congruent. If we know that two triangles are congruent, then we know that every pair of corresponding parts is also going to be congruent to each other. All right, so let's list all the congruent angles and sides given the congruency statement. So if I have triangle JKL is congruent to triangle PQR, that means that angle J is congruent to angle P because they're both the first letter. Angle K is congruent to angle Q because they're both the second letter, and angle L would be congruent to angle R. And then the sides, JK is the first and second letter. That would be congruent to PQ. That's the first and second letter. And KL, the second and third letter, it would be congruent to QR, the second and third letter. And then JL, the first and third letter, would be congruent to PR. Now, if you wanted to draw a picture, you could actually draw a picture, JKL, and then next to it, you could draw a PQR. It doesn't matter where you put the JKL, but wherever you put that J, you need to put the P in the same spot. Wherever you put the K, you have to put the Q in the same spot. Okay? Let's look at this one on the bottom right here. So given triangle KPM, so that's this one right here, is congruent to AYC, complete each of the following statements. So KM is the first and the third letter right here. So KM, which is right here, would be congruent to the first and the third letter, AC. Okay, and you'll have a couple of questions, maybe 2 questions like this on your test. CY, well, let's find CY. I'll do that in a different color. CY is the third and the second letter. Well, that would be congruent to MP. So CY would be congruent to MP. And then we have PK So PK is the first and the second letter, or second and first. That would be congruent to YA. All right, so angle Y is congruent to angle P, because Y is the second letter and P is the second letter. Angle K is congruent to angle A. They're both the first letter. And angle ACY, this might be a little bit harder. ACY, let me erase some of this right here so we can see these again. All right, so ACY, ACY, so first, second, third. I'm sorry, first, third, second, ACY. So A, then C, then Y. So same thing, K, then M, then P. See how I'm doing the same order of the letters? K, then M, then P. And then if I could say that triangle MPK, so MPK, see how I'm going MPK, I'm just going in reverse order, is congruent to triangle CYA. All right, let's flip this over, and we are going to show how to prove triangles are congruent. There are 5 ways listed here, so I'm just going to briefly introduce them to you, and then we're going to go and do proofs in more detail in each of the lessons. So basically, when you have 2 triangles congruent to each other, there are 6 things that are congruent, 3 angles and 3 sides. But you don't have to prove all 3 things. So these are like shortcuts to proving triangles are congruent. Side, side, side. Basically, you have the 3 sides of one triangle congruent to the 3 sides of the other triangle. Side angle side means that you have 2 sides of one triangle congruent to 2 sides of the other, and the included angle, meaning the angle between those 2 sides, is also congruent. Angle side angle means that this time you have 2 angles and you have the included side between those 2 angles are congruent. And angle side means that you have 2 angles congruent to 2 angles and a side. It doesn't matter which side, but the side is not between the 2 angles like it was above for angle side angle. Again, these are shortcuts for proving the 2 triangles are congruent. And the last one is hypotenuse leg. You have to have a right triangle. So these are both right triangles, and you have the hypotenuse, which is across from the right angle, and you have one of the sides. It does not matter which side that you have. All right? So how are these proofs going to work? Basically, you might have information in the given. You might have something in the given that tells you it's a midpoint or a bisector or something like that. And one thing that you have to look for is you're going to have to look for to see if they have a side that they share. And I'll show you what that looks like. What are some reasons that angles are congruent? Again, it might be in the given. You might have vertical angles. That might be something you have to look for. If you have parallel lines, you could have alternate interior angles or alternate exterior angles or corresponding angles. Or you might have an angle bisector. So these are 2 things that are not going to be in the given that you need to look for. Okay, so if you have 2 lines that intersect like this, these angles that are opposite each other are called vertical angles. So we talked about that already. So I would just say angle 1 is congruent to angle 2, and the reason would be that vertical angles are congruent. And if you have 2 triangles that share a side like these do, then I would just say AC is congruent to AC. They share that side. That means that side, has to be the same length in both of them. Okay? So, let's look at this, and we got to figure out why these triangles are congruent. So remember, there's always 2 things that we have to look for. Do they share a side? Look at question 1. They share this side. So now let's figure out why the triangles are congruent. I have an angle, a side, and an angle. So I have 2 angles and 1 side. Is the side between the 2 angles? Yes, it is. So it's angle, side, angle. Question 2. Again, these 2 share this side. So now why are the triangles congruent? Side, side, side. 3. I have 2 angles and a side, and 2 angles and a side. So 2 angles and a side is either angle, angle, side, or angle, side, angle. So the question is the side between the 2 angles? No, it's not. So this one is angle, angle, side. On 4, they share this side right here in the middle, and they have right angles. This is hypotenuse leg. Okay, so we're just marking up the diagrams by adding in anything that's not there that we should know. Number 5, I have these nice vertical angles here. I have 2 sides and 1 angle. 2 sides and 1 angle, if I peek up here, is not a reason. It's either 3 sides, or it's going to be 2 sides and an angle, but the angle has to be between the 2 sides. It does not work for side, side, angle. Okay, so side, side, angle is not a method, so these are not congruent. 6 is getting a little bit harder. These symbols right here mean that the lines are parallel to each other. If they're parallel to each other, then these angles right here are corresponding angles. So this is going to be angle, side, angle. See how I have 2 angles and this side between them. So that's angle, side, angle. Number 7, they share this side right here. So I have 2 sides and the angle between them. That's side, angle, side. 8, they share the side in between. So now I have side, side, side. 9 actually has a whole bunch of different ways that I can use. Just based on the way it's marked, I have hypotenuse leg. But I also have these angles because they're vertical angles. So I also have angle, angle, side. Okay, I guess those are the only 2 ones. I just have 2 of those that I could have. 10, I have these nice vertical angles. So therefore I have angle, angle, side. So I have 2 angles and a side, but the side is not between those 2 angles. And 11, I'll move this up a little bit so we can see. 11, they share this side in between. Okay, but I just have 1 angle and 1 side, and that is not enough, so these are not congruent. And 12, again, these lines are parallel to each other, which means that these alternate interior angles are congruent, or it also means these alternate interior angles are congruent. And I also have these vertical angles. I got tons of angles. I got angles all over the place. Okay, so if you have parallel lines, generally you're looking for alternate interior angles. You might sometimes have corresponding like we had up above, but generally it's just going to be alternate interior angles, and you also have these vertical angles here. So on this one you either have angle, side, angle, or side, angle, side, or angle, angle, side. You actually have 3 choices for what you can do on that one. All right, so we're going to practice some more of this tomorrow,